what we are looking at in 2.2 is we are continuing to solve equations. Now we're just going to add a couple more steps into a problem that we already know how to do. So the first couple here, this is going to be a little bit of review. So for the first one, it says solve 4/3 x minus 7 equals 1. So we want to think, okay, well, what do we know we can do? We look at the variable. Oops, that's what I wanted. We look at the variable and we say, okay, it's being multiplied by this 4/3. There's also be a 7 subtracted from it. We can address that first. So one thing we can do is add a 7 to both sides. So we're left with 4/3 x, and then when we add a 7, we get 8. Now, we can also rewrite this. Keep in mind, we can rewrite this as 4x over 3 equals 8. Now you can say, all right, the dividing of a 3. So we want to multiply by a 3. So on the left, they cancel out. You're left with 4x equals, and then 24. The next thing you want to do is divide by 4 to get x equals 6. We're going to be talking about another process called clearing fractions that you could have also applied to question number 1. Example 2, 45 minus t equals 13. Well, we know we have our variable with a negative, but we also have this 45. We need to get rid of this first. So what we want to do is subtract 45, right? And when we do that, we're left with negative t equals, and again, use your calculator to type this. 13 minus 45 gives us a negative 32. However, we still have this negative in front of the t, so we need to divide by a negative 1 to get t equals a positive 32. We're going to continue on with some problems with a little bit more steps within them. And this is where these steps here are going to be very helpful. So with each problem, you have to simplify first, which means you need to distribute anything, clear fractions, which we'll talk about, combine any like terms, move your variables, move your constants, and then multiply or divide. So let's go ahead and look at some examples that involve all those steps. So example 3 says combine like terms. So we said first that we need to, there's nothing to distribute here, but we do have to combine like terms. So we have a 6x and a negative 7x, which leaves us with, right, a negative x plus 5. And on the right-hand side, you have a 10 and a 7, which is 17, minus a 4x. Now you'll notice that we have x's on both sides of this. We notice that a negative 4 is smaller, so I'm going to move that one. I'm always going to move the smaller variable term. So start with the equal sign. We know we need to add a 4x, which will leave us with a 17 on the right. And when we add a 4x to a negative x, right, we're left with 3x and then the plus 5. Now we have to move the 5. Well, since it's being added, we want to do the opposite. We want to subtract it. So when we do 5 minus 5, we're just left with 3x on this side. 17 minus 5 is 12. Last but not least, divide by 3 to get x equals 4. Now I want you to try example 4. The only difference between this one and the previous one is that now we have to add distributing it. So go ahead and try this. Check your answer when you're done to see if you got it correct. For this one, you should have found an x equals negative 2. If you did not get that, that means you didn't check your answer well. So what we did here, first distribute the negative 5 to get negative 5x minus 25, distribute the 3 to get 3x minus 6, and then combine the like terms to get negative 23, and combine these like terms to get negative 7. I moved the smallest variable first, which is negative 5x, and then I move the negative 7, and then I divide by an 8 to get an answer of negative 2. Okay, now we're going to talk about the idea of clearing fractions. Now we've already worked with some problems that have fractions in it, but we're going to learn a process of clearing the fractions. This is going to be the way you need to solve all your problems that involve fractions, especially if there's multiple fractions, because these problems are the ones that are the most difficult. When you see a problem involving fractions, you must clear them unless they're a very simplistic problem like we looked at in the first section. But get into the habit of always clearing fractions to make it easier. So then the steps here says 1, distribute if needed, find the LCD, and then distribute the LCD to both sides. So when we look at this first one, we see negative 1 over 8, a y over 1, and a negative 3/4. The LCD of this, right, would be 8. So now what we have to do is distribute an 8 to both sides. So I'm going to start by rewriting the equation. Now I'm going to write it with the distributing of an 8 to both sides. Now we want to watch our distributing. 8 times a negative 1/8, if you need to, use your calculator, but right, that would be a negative 1. And then 8 times y would be 8y. And then we just have 8 times negative 3/4. One way you can think of this is you can say, okay, 4 goes into 8 2 times. 2 times negative 3, right, would give us a negative 6. Or you could think of it, 8 times negative 3 is negative 24 divided by 4, or type it in your calculator. Now, the only thing we have left, well, 2 steps left. One, we still have to get this isolated, so we need to move this over to the other side. So if it's a negative 1, we have to do the opposite, which would be add 1. So we're left with an 8y, and then negative 6 plus 1 is negative 5. And then we have to divide. We have to divide both sides by an 8. Well, 8y divided by 8 is y. But now when we do negative 5 divided by 8, right, we're just left with a negative 5/8. We're going to leave it like that. We never, ever, ever want to use decimals in our answer unless the original problem has decimals in it. Always leave it as a reduced fraction. So leave as a reduced fraction. Now, the next one. Actually, let's have you pause the video and I want you to try this one out. Follow the steps we did here, identify your LCD, then distribute it to both sides, and then solve it. And then I want you to make sure you check your answer. With this problem, you get an answer of a negative 1/8. If you did not get that, go back and double check your steps. Again, make sure you're writing this step out right here. This is going to be what's going to help us through the problem. Okay, next page. Ooh, another one. So let's go ahead and try this one. The difference here is now we have some distributing. Look back at those steps we have. We said that you always want to distribute first and then clear your fractions. So I want you to go ahead, pause the video, and try working through this one. So first, when you distribute, you should get 6x over 5, because you have to do 2 times 3x is 6x over 5, and then 2 times 2 is 4 over 5 equals 8. And then you have to find the LCD. So go ahead, and if you did not finish or you did not get that step, fix that and then try the rest of it. Okay, when we do this, we find the LCD to be 5, so we have to distribute a 5 to both sides. So we do 5 times 6x over 5. Well, the 5's cancel, so you're left with 6x. 5 times 4/5, the 5's cancel, you're left with a 4, and then 40. Subtract your 4, divide by 6 to get x equals 6. All right, the last idea we're going to talk about is conditionals, contradictions, and identities. So these are going to be some definition words that you want to make sure you know. So we have conditionals, contradictions, identities. What a conditional is, it's going to be an equation that is true for some values, but not for others. Everything we've looked at so far is a conditional. It's saying, for example, in the previous one, this equation is true under the condition you use 6. So it's true for this value, but not for others. A contradiction means there isn't any solution. So there is no solution. That means there isn't anything that would make that equation true. Whereas an identity means anything would make it true. So we would say any real number would make it true. So let's look at this example. Now this is an equation you know how to solve. First thing we have to do is simplify both sides. Well, on the left, there's nothing to do. So we just have this 3x minus 5. But on the right, we have to distribute. So we get 3x minus 6 plus 4. On the right-hand side, we have to combine like terms. Negative 6 plus 4 would be a negative 2. And we have here on the left, 3x minus 5 still. Now, we always move the variable term first. You see a 3x and a 3x. Well, you notice they're the same thing. So if you subtract a 3x from both sides, right, 3x minus 3x on the left, you're just left with a negative 5. 3x minus 3x on the right, you're left with a negative 2. This is not a true statement, which means this would be a contradiction, which means there is no solution. this would be the answer to this problem. We're not going to use the term contradiction, condition, or identity as the answer, because our answer is always going to be the solution set. What's the solution set? There is no solution. All right, go ahead and try example 9. Okay, you can see for this one what happens is when we distribute and then combine like terms, we're getting the same exact thing on both sides. And you move the variable term, you realize that the variable term gets eliminated and you're left with a statement of 7 equals 7. Since that is a true statement, that means the solution here is all real numbers. Meaning if you pick any real number off the number line and substitute it into this, it'll make that equation true. So the last thing here is, what is the solution set of an identity? Well, this is what we just talked about. The solution set of identity is all real numbers. The solution set of a contradiction, right, there is no solution. Again, if you find a contradiction or identity, meaning the variable was eliminated within the problem when you were solving, then you answer with either all real numbers or no solution. Contradiction or identity, that word is not the answer. Okay, if you have any questions, feel free to reach out and let me know. Good luck.